Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this video we will learn about service discovery design pattern for microservices. Yes friend, in this video I'll explain you what is service discovery design pattern, where to use it, what are the advantages of this design pattern, and I will also give you a real world example of this design pattern. We'll understand what is service discovery in this tutorial in detail. So stay tuned and watch this video till end. It is going to be very exciting and informative tutorial for you. There is a lot of learning involved in this video. Friends, in a previous video, we discussed about external configuration design pattern. Can you explain what is external configuration design pattern all about? Provide your answer in the comment section of this video. And if you have not seen that previous video, so please go and watch that video. The link is given on your screen and also given in the description section of this video. So for more information, go and watch the previous video on Code One Digest channel.
He has an agenda.
So friends, here is the agenda of this tutorial today. I will give you an introduction of service discovery design pattern for microservices. Then I'll show you the real world example of service discovery design pattern. Then I'll explain you where to use it, what is the use cases of service discovery design pattern. And we will also understand the advantages and benefits of service discovery design pattern for microservices. And at the end, I'll summarize what we learned in this tutorial. So stay tuned and watch this video till end. It is going to be very informative tutorial for you. Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming, coding concepts, design pattern and design principles, cloud and container technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you.
All right, let's get started.
Okay friends, so now let's start with the service discovery design pattern. This is a second design pattern in cross-cutting concern design pattern category. The service discovery pattern uses a centralized server named service registry to maintain a global view of microservices network locations. What does it mean? The service discovery pattern is mainly used in microservices application to find the network location of microservices, where the microservices are running, what is the IP address and port of the microservices. So all of that information are stored in a service registry. Microservices updates their location, that is IP address and port, in the service registry at the fixed interval. So every microservice keep updating their location and port information into service registry so that the information in service registry is up to date. Client can connect to the service registry and fetch the location of microservices they are interested in. So let's say a client want to access a service A. So it will go to a service registry and find the IP address and port of service A. Why it is important? Because in microservice architecture, we normally deploy our services into a Docker containers and being managed by some orchestrator framework like Kubernetes, etc. It is tend to change the IP addresses of microservices because we keep creating and destroying the microservice instances in Docker containers. Hence, the IP address keep changing for these microservices. So in that scenario, we cannot rely on a fixed IP address information. There should be a repository where this IP address and port information are available and up to date, and services themselves are updating this information into a central repository at regular interval. So service discovery pattern is all about the same concept. In this registry, we maintain the IP address and port of all the microservices, and each microservices keep updating their location information at regular interval so that the consumer of these APIs, consumer of these microservices finds the right IP address and port information.
Oh, wow. That's amazing.
Okay, friends, so now let's understand how the service discovery works. There are primarily three participants in this service discovery design pattern. What are they? The first one is service registry itself. That is a repository where the location information of each microservices are stored. We store the IP address and port information in this registry for all the microservices. The second is the client, that is the consumer of microservices who wants to access your microservices. And third are microservices itself. Microservices get registered on the service registry and share their location information regularly with the service registry. The service registry keeps the record of network location of microservices. Microservices instance register themselves and provide their location to the service registry. Then client can find the location of microservices using the service registry and directly call them to fulfill their request. Let's understand this with the diagram, what you see on your screen. There are four parts of service discovery communication. First, the microservice registers its location in the service registry. Second, the client looks for the relevant service location in the service registry. Third, the service registry returns the location of required microservice. Fourth, the client directly calls the microservice. Right, friends? So this is the communication between these three components to know the location of microservices.
What the hell are you talking about?
Okay, friends. So now let's understand what are different type of service discoveries are supported. So there are two main service discovery pattern available to implement. First is client-side service discovery and server-side service discovery. Let's see what is client-side service discovery. Client-side service discovery, the client is responsible for finding the network location of the microservices and load balancing the request between them. So assume you have multiple instances of microservices running, two or three instances of same microservices running. So client is responsible to find the location of these services from service registry and also responsible to load balancing the request between these three microservices instances. As I said, there are three instances are running of the microservices. So client has to take the responsibility of load balancing the request between these three services. Right, friends? So the client queries the service registry and retrieves the location information of microservices. Then client uses its dedicated load balancer to select a microservice and sends the request to individual instance. When using client-side discovery, the service consumer is responsible for determining the network location of available service instance and also load balancing the request between them. Giving the responsibility for client-side load balancing is both a burden and an advantage. It's an advantage because it saves an extra hop that we would have had with an external load balancer. It's a disadvantage because the service consumer must implement the load balancing logic. You may have n number of consumers of your API and you cannot enforce them to implement a load balancer. In that sense, this approach is a disadvantage. A popular example of client-side discovery is Netflix OSS, where the service registry is Netflix Eureka. It provides a REST API that manages the integration of service instances and querying available instances. Netflix Ribbon works with the Eureka as an IPC client to deal with load balancing functions while requests are made to available service instances. The advantages of client-side service discovery is it is straightforward and easy to understand. The service registry is the only moving part. The client knows the location of microservices before sending the request. The client can make intelligent load balancing decision with its dedicated load balancer. There are some disadvantages of client-side service discoveries are the client is responsible for implementing the service discovery logic and you cannot enforce all the consumer of your API to implement load balancing logic. And the client need to implement a service discovery logic for each language used by your client.
Wow.
Okay, friends, so now let's understand the server-side discovery pattern. The server-side discovery pattern solves one of the significant issue in client-side discovery by decoupling the client and the service registry. In this approach, the client does not have a dedicated load balancer. Instead, the load balancer acts as a middleman between the client and the service registry. The load balancer is responsible for communicating with the service registry. First, the client sends a request to a load balancer. Then load balancer query the service registry and find the location of a relevant microservices. Finally, the load balancer routes the request to the required microservice. This pattern is widely used in modern applications since both client and microservices are independent of service registry. And more than that, the client don't need to implement load balancer from scratch because many cloud provider already provides the load balancer. For example, you can use AWS Elastic Load Balancer or proxies on the Kubernetes environment as a server-side discovery load balancer. The advantage of server-side service discovery pattern is the service registry is decoupled from the client. This approach can use the load balancer provided by the infrastructure provider. Some of the disadvantages of server-side service discovery are if the deployment environment does not provide the load balancer, then developer need to create and manage the load balancer.
Really?
Friends, as we are talking about service discovery and service registry, so let's understand what is service registry all about. The service registry is a database containing the location of all microservices, that is IP address and port. Therefore, it should be highly available and continuously updated. So it is essential to have a reliable mechanism to continuously update and maintain the data consistency in service registry. Microservice is registered in a service registry when the service starts up. It continuously updates its registration information using a heartbeat mechanism. Finally, when the microservice instance terminates, the registration is removed from the service registry. There are two approaches to handling the registration process in the service registry: self-registration and third-party registration. In self-registration, the microservices are responsible for registering themselves in the service registry. Once the microservices is registered, it will keep sending heartbeats to ensure that registration does not expire. This approach is straightforward and does not require any third party to be involved. Third-party registration. In this approach, a new component named Service Registrar is responsible for registering and deregistering the microservices. In addition, the Service Registrar tracks the location change of microservices by polling the deployment environment or subscribing to the event. Many modern deployment environment provides a built-in component as Service Registrar. For example, if you create EC2 instance in AWS Cloud using an auto-scaling group, it will automatically register with an elastic load balancer. Few examples of service registry are etcd, a highly available distributed consistent key value storage that is used for shared configuration and service discovery. Two notable projects that use etcd are Kubernetes and Cloud Foundry. Consul. Another example of service registry is Consul, a tool for discovering and configuring the services. It provides an API that allows client to register and discover the services. Consul can perform health check to determine service availability. Third is Apache Zookeeper, a widely used high-performance coordination service for distributed application, is mainly used with Kafka. Let's understand the self-registration. As I said, self-registration, microservices are responsible for registering themselves in the service registry. Once the microservices is registered, it will keep sending heartbeats to ensure that registration does not expire. This approach is straightforward and does not require any third party to be involved. Let's understand third-party registration. In this approach, a new component named Service Registrar is responsible for registering and deregistering the microservices. In addition, the Service Registrar tracks the location change of microservices by polling the deployment environment and subscribing to the events. Many modern deployment environment provides a built-in component as Service Registrar. For example, if you create an EC2 instance in AWS Cloud using an auto-scaling group, it will automatically register with an elastic load balancer.
What? I do not understand.
Okay friends, so now let's understand the service registry with a real world example. Let's understand the problem first. When you're working on a microservice application, you have to deal with service instances that have dynamic locations, that is, dynamic IP address and ports. This instance might also need to be changed at runtime based on the factors such as auto scaling, service upgrades, and failures. In such scenario, the consumers of these instances must be aware of the changes. In microservice architecture, the number of instances will vary and will not have their location in the configuration file. Thus, it is difficult to know the number of services at one point. So the solution is you need a service discovery in a microservices to locate the service instances dynamically. A popular example of client-side discovery is Netflix OSS, where the service registry is Netflix Eureka. It provides a REST API that manages the integration of service instance and querying available instance. Netflix Ribbon works with the Eureka as an IPC client to deal with load balancing functions while requests are made to available service instances. A popular example of server-side discovery is AWS Elastic Load Balancer (ELB). The Elastic Load Balancer is used to balance the load of external traffic from the internet as well as the internal traffic directed to a virtual private cloud.
What does that even mean?
Okay, friends, so now let's understand the use cases of this design pattern, where to use service discovery design pattern in our project. Use this pattern to have a central repository of microservice locations. Use this pattern to avoid restart of dependent services when an IP or port of required services changes. Use this pattern to allow client to discover the location of service automatically at runtime.
Wow. That's amazing.
Okay friends, now let's understand the advantage of this design pattern. What benefits we get out of this service discovery design pattern. It is a central repository of microservice location, hence we have all the information at one central repository. Using this pattern avoids the need to restart dependent services when IP or a port of a required service changes, because it is taken care by a middleman, that is our load balancer. Client can discover the location of required service automatically at runtime. Yes, so if there is a change in IP address or a port for a given microservice, so the consumer can automatically get the updated information from a central repository. Okay friends, so now let me summarize what we learned in this tutorial today. I gave you introduction of service discovery design pattern. We understood what is service discovery, what is service registry, what are the participant in this pattern, what is service registry, what is client, and what is microservices, and what are their rules, what are the messages they exchange with each other. Then I explained you, shown you the real world example of service discovery design pattern. I also explained you the different types of service registry like server side discovery pattern and client side discovery pattern. We also understood the different types of registration, that is self registration process or registration through a third party component. Then we also understood the use cases of service discovery design pattern. I also explained you the benefits and advantages that we get using service discovery design pattern. So friends, let me know if you have used this design pattern in any of your project or seen a scenario where this pattern can be useful. So provide your answer in the comment section of this video.
Sounds good, man. Sounds good. Good plan. Good talk, all right?
Friends, in the next video, I'll discuss the circuit breaker design pattern. I'll explain you what is circuit breaker design pattern for microservices. I'll also show you the real world example of circuit breaker design patterns. I'll explain you the use cases of circuit breaker design pattern, and we will also understand the benefits and advantages of circuit breaker design pattern. So stay tuned for the next video and keep watching Code One Digest. And if you're new to the channel, so please do subscribe to our channel to grow Code One Digest family. Thank you.
This is not rocket science.
Friends, if you like this video, so give it a thumbs up. and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents, so please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.